Latent heat and specific heat are two most important properties in thermodynamics. Both represent heat supply to any object, but for different purposes. First of all, let's talk about latent heat. We all know that any object can exist in three possible states: solid, liquid, and gas. And at any moment, this physical state depends on two factors: pressure and temperature. If pressure is kept constant and temperature increased, state change from solid to liquid and liquid to gas. For example, let's take an ice cube which is supercooled at minus 10 degrees Celsius and its mass is 1 kg. As soon as you supply heat to this ice cube, its temperature increases, which can be seen on this temperature and the heat supply graph. This line represents continuous change in temperature with respect to heat supplied. But something strange happens when the temperature reaches 0 degrees Celsius. Even the heat is being supplied, there is no change in temperature. Instead, this ice cube starts melting at this point. There is no change in temperature, which is represented by this flat line. But as soon as the whole of the ice cube has melted away, the temperature starts increasing again. Now, during this period, heat absorbed by the ice cube without any change in temperature is known as latent heat. There are two kinds of latent heat: latent heat of fusion and the latent heat of vaporization. For ice, latent heat of fusion is 335 kJ per kg. It means 335 kJ of energy required to change 1 kg of ice into liquid water at 0 degrees Celsius. Now let's talk about specific heat. Before that, we have to know about sensible heat. The heat supplied during these inclined lines is known as sensible heat. This heat changes the temperature of the object. Amount of sensible heat which change the temperature by 1 degree Celsius or 1 kg of substance is known as specific heat. For water, the specific heat is 4.2 kJ per kg. It means 4.2 kJ of heat is required to change temperature by 1 degree Celsius. Different substances have different specific heat. Metals have lower specific heat compared to water, and that's why when you supply same amount of heat to metal and water, the metal feels much hotter than the water. There are two kinds of specific heat: specific heat at constant volume and the specific heat at constant pressure. Gases have both types of specific heat, but liquid and solid have only specific heat at constant volume because they have constant volume.